All right, so I am going to be working through some of the problems in the exam review that I sent out to everyone. So I don't know if all of you got a chance to take a look at those questions and maybe practice with some of them. So I'm going to work just a few problems from each of the different parts or sections in that review. And so I'll start with some problems from part 1, which is graphing trig functions. And I'm just first going to ask the people who are here right now, were there any questions that you wanted to see me work on in particular from part 1? If not, then I'll just pick a few to work out instead. Okay, so someone wants to look at problem number 4, so we will do that. Any other questions from part 1 that you guys really want to see? All right, so I'm going to start with looking at problems number 3 and 4 from part 1. After I finish those two, I might see if there's a desire to look at one more, but I'll go ahead and just start with numbers 3 and 4 then. All right. So here I went ahead and drew just little sketches of the graphs of each of our 6 trig functions. And here I've graphed a 1 period for each of them. All right, now, it's important to know what these graphs look like because it helps you in graphing like variations on them. So let's take a look at problem number 3 from the review. Okay, so the function that we have is -1/2 sine of pi x over 2 minus pi and then plus 2. All right. And so we want to graph at least 2 periods of this function. And then we also want the amplitude and the period. All right. So let's start with the easier part first. So let's talk about the amplitude and the period. All right. So in general, if we have a sine function of this form, a sine kx minus p, and then maybe plus b. All right. So here, this is kind of like a generic sine function. And so based off the constants in our function, we can determine the amplitude and the period. All right, so to get the amplitude, so the amplitude is given to be the absolute value of whatever the coefficient of sine would be. So here's, I've labeled the coefficient as a, so the amplitude would be the absolute value of that. To get the period of this function, okay. So the period is affected by the coefficient of x. So here I have the coefficient of x being equal to k. So whatever that coefficient is, the period is going to be equal to 2 pi over k. let's see here. I guess maybe in case it's negative, you can do absolute value. That would be good as well. All right. So looking at the function that we have right now, so the coefficient of the sine function is -1/2. So the amplitude should be the absolute value of that. So we would say the absolute value, or sorry, the amplitude would be equal +1/2. Now looking at the period, all right, so the coefficient of x in this function is pi/2. So to get the period, I'm going to take 2pi and I'm going to divide it by pi/2 because that was the coefficient of x. And here, since I'm dividing by a fraction, if I wanted to simplify that, I would simplify by multiplying by the reciprocal. Okay, so when I do that, here the pi's are going to cancel out. So I'm going to be left with 2 times 2. So in the end, the period for this function would be equal to 4. All right, so any questions so far about getting either the amplitude or the period? All right, so if you guys have any questions about anything at any time, post them in the chat and I'll take a look, all right? So we have the amplitude and we have the period. Now the harder part of the question is trying to graph it. Okay. So to graph it, right now we have a sine function. Okay, so for the sine function, if you're trying to graph a sine function, so it's useful to keep in mind what the generic sine function looks like. So we know that for sine, it's equal to 0 at like 0, pi, and 2pi. It reaches its peaks at pi/2 and 3pi/2. And it completes one period from 0 to 2pi. So when I have a more general sine function like how I have here, so what I'm going to do is I'm going to create a little table. So I'm going to start with what I have inside the sine function. So inside of the sine, I have pi x over 2 minus pi. So I want to be focused on when this is equal to 0, pi/2, pi, 3pi/2, and 2pi. So I start with these values because I know what sine is equal to at those values. So sine at 0, we know sine of 0 is 0. Sine of pi/2 is 1. Sine of pi is 0. Sine of 3pi/2 is -1. And sine of 2pi is 0. Okay? So I'm going to start with this, and I need to do two things in my table now. So what I'm going to do first is, from this sine that we have here, I'm going to First, multiply it by -1/2. Okay. To get it closer to the function that I'm trying to graph. So if I multiply all of these by -1/2, we get 0, -1/2, 0, +1/2, 0. And the last thing I need to do is I also need to add 2 to everything in order to get the function that we're trying to graph. So I'll add one more column where we just add 2 to what we had before. So I'm going to add 2 to each of these values. So 0 plus 2 is 2. And for these fractions, if I'm trying to add 2 to everything, so adding 2 is the same as adding 4 over 2. So that would leave me with 3 over 2 and 5 over 2 in this column, okay? All right, so this is the function that we're trying to graph. All right, now something else that I'm going to need to do in my table, though, is here I've figured out the values of my function, but I have the values in terms of the values of what was inside the sine function, so this. What I need to do now, though, is I need to, starting from what we had inside the sine function, I need to work my way to solving for x. So if I wanted to isolate x, what I would do first is add pi to everything to get rid of this minus pi. So right now, if I'm just going to add 1 pi to everything, so adding pi, you can think of it as adding 2 pi over 2. So I'll get 3 pi over 2 here. Adding pi is 2 pi. Here, if I want to add pi, think of it as 2 pi over 2. That'll give me 5 pi over 2. And then here, adding pi will give me 3 pi, okay? Yeah, so add pi to get to this. And if I want to solve for x, what I would now do is to get rid of the pi over 2, I would need to multiply by its reciprocal. So I'm going to multiply everything by 2 over pi. And that way I will have solved for x. So multiplying everything by 2 over pi. So I'm going to get 2 for this. So 2 over pi, if we multiply, the 2's cancel. Pi's cancel, so we'd be left with 3. Here we're multiplying by 2 over pi. The pi's cancel, we're going to get 4. And if you continue, you're going to get 5 and 6. All right, great. So now that I've solved for x, so here are my x values, and then here are the corresponding values for the function. So what I can go ahead and do is I can go ahead and start graphing these points. All right, so I'll start by drawing my xy axes. Okay. So here I have spacing 1 unit apart, so 1, 2, 3, 4, 5, 6. Okay. And then here for my function values, these are going to be values of y that I will need to plot. So let's say here is 2. Say that's 1, and that's 3. Okay. So the first point on our graph is going to be the point 2, 2. So that would be roughly here in my picture. Next, we have the point 3 pi over 2. Or sorry, just 3 over 2. So that's 3, and then 3 over 2 is 1.5. So it's going to be halfway between 1 and 2. At 4, I have 4, 2. At the point 5 and 5 over 2. 5 over 2 is 2.5, so it's a little bit higher. And then I have the point 6, 2. Okay. So I plot my points, and then I'll connect them like that. Okay. And so what I have done right now is I've managed to graph one period of our function f of x. Okay. Now, once we have one period, to graph a second period, we just need to start repeating this now. Okay. So imagine starting from the beginning. So I would go down to 3/2 here, and go back up to 2, then I go up and then back down. And then I'll just connect these, and that will give me a second period now. Okay. So that will be a rough sketch of 2 periods of our function f of x. Okay, so I'll kind of pause there right now, and I'll just check with everyone, see if you guys have any questions. Okay. Yeah, so I recommend, at least for me personally, I find it easiest to make the graph by making this table. Okay. All right, so I will go ahead and move on, and let's take a look at problem number 4 from the review. Okay, so in problem number 4, this time we have a tangent function. Okay, and so for this tangent function, there's a couple parts to the problem. So we want to know the period, the range, all right. So tangent has some vertical asymptotes. So here we want the equations of 3 consecutive vertical asymptotes. And then lastly is graphing 2 periods, at least 2 periods. All right. So let's talk about how to get things like the period and the range and so forth. Okay, so for the tangent function, in general, let's say we have an equation, I'll write it like this. So let's say we just have this like general tangent function. So if you want to get the period of the tangent function, so it's similar to what we saw for the sine function. The period is affected by the coefficient of x. But for tangent, to get the period, you're going to do pi and then divided by the coefficient of x. And that's how you'll get the period. Okay. For the range of such a tangent function, so actually it's not going to matter what all of the numbers are in your function for a tangent. The range is going to be everything from minus infinity to positive infinity. Okay. So let's start with those two first, looking at our function f of x. All right, so to get the period, okay, so the formula is pi, and then we divide by the coefficient of x. So in this problem, the coefficient of x was 4. So that makes the period of our function pi over 4. All right, and then as I noted for the range, okay, so for a tangent function, the range is going to be all real numbers. So using interval notation, it's everything from minus infinity to infinity. Oh yeah, of course, yes. I'm just used to having positive numbers, but yeah, in the event that it was negative absolute value, just so that you have a positive answer for your period. Yeah, thank you. Good. All right, and then let's talk about part C and D. So trying to graph our function and also finding these vertical asymptotes in the process. So the way I'm going to do this is going to be similar to what I did in the previous question. I'm going to start by making a table. And I'm going to start with the expression inside of the tangent function. Now, tangent, what I know about the ordinary tangent function is that at negative pi over 2, it has a vertical asymptote. I know that at 0, tangent is equal to 0. And then I know at pi over 2, it has another vertical asymptote. And I know from negative pi over 2 to pi over 2, that's one full period of the tangent function. Okay. So what I'm going to do right now is kind of like what I did before. But this time, let me work backwards first. So let me figure out what x is going to be. So the first thing I'd want to do is subtract pi over 4 from everything here to get 4x. All right. Okay, so if I'm going to subtract pi over 4 from everything, all right, so think of this as 2 pi over 4. So minus 2 pi over 4 minus another pi over 4 will leave me with minus 3 pi over 4. Okay? Next we have 0 minus pi over 4. So we get minus pi over 4. All right, and then pi over 2 minus pi over 4. So again, common denominator, so make this 2 pi over 4. So 2 pi over 4 minus 1 pi over 4 leaves you with 1 pi over 4 remaining. Okay? And if I divide everything by 4 now, that is going to leave me with x. Okay. All right, now dividing by 4, that's the same as multiplying by 1 over 4th. So it might be easier to think that you're multiplying by 1/4 to everything. So if we multiply by 1/4, we'd get negative 3 pi over 16. Negative pi over 16, and then pi over 16 right now. Okay. So right now that gets me the equations of two vertical asymptotes. So one vertical asymptote is when x is negative 3 pi over 16. So we get another vertical asymptote when x is equal to pi over 16. And another question was asking for 3 vertical asymptotes. So if I want to find one more vertical asymptote, so I can just sort of go down to where the next one would be. So negative pi over 2, 0 pi over 2. Okay, so I know at pi, tangent becomes 0 again. And then adding another pi over 2 will give me 3 pi over 2. And that would be where the next vertical asymptote occurs. All right, so if I just subtract pi over 4 from everything, pi minus pi over 4, that would be 3 pi over 4. 3 pi over 2 minus pi over 4. So 3 pi over 2 is the same as 6 pi over 4. We're going to minus pi over 4, so it becomes 5 pi over 4. And then if I multiply everything by 1/4, give me 3 pi over 16, and then 5 pi over 16. Okay. So here I found a third vertical asymptote at 5 pi over 16. And then this would be like one set of 3 consecutive vertical asymptotes. All right. Okay, all right. So then we have our 3 vertical asymptotes. And the last thing we want to finish up is graphing two periods of our function. Okay, so here I've worked out the tangent. So what I now want to do is kind of build up from this to our function. All right, so to get our function, the first thing we'd want to do is we need to multiply this tangent by 2. I guess after multiplying by 2, we'd also add 1 to everything. This would be our function f of x. Okay, so, all right. So we still have vertical asymptotes here for now. So I'm just going to keep labeling them as vertical asymptotes. And then here we have 0. So if we do 2 times 0 plus 1, so each of these will be 1. All right. And so that's going to give me information to graph our function now. So let's get to that. Okay, so what I'm going to do for the graph is I want to plot the information in my table. So I'm going to start by putting these x values. All right, let's see, negative pi over 16 would, let's say it's going to be about here. And then negative pi over 16, I'll say it's about here. Pi over 16. Okay. Now, these should be equally spaced, so I'm going to try to make my picture a little bit more to scale. So negative 3 pi over 16, maybe out here. And then 3 pi over 16 would maybe be here or so. And then 5 pi over 16 would be about here. All right, so I plot my x values. Now we know that at negative 3 pi over 16, we should have a vertical asymptote. Also at pi over 16, and also at 5 pi over 16. Okay, so here's me labeling the vertical asymptotes. And then I know at negative pi over 16, we should be at a y value of 1. And then same at 3 pi over 16, we should be at a y value of 1. Okay. Now after that, remember that the tangent function, so remember that its graph looks like this in between its vertical asymptotes. So then here I'm just going to draw a similar figure between each of my asymptotes. Let's see here, going up like that. And then again, starting from here, so kind of draw the shape of tangent, so it looks something like this. Okay, so that's going to give me a sketch of my tangent function. Now I'll make a note right now that Okay, so one thing that you do need to be careful about is the coefficient of your tangent function. Okay, so if the coefficient is positive, then it should resemble a ordinary tangent function, but if the coefficient is negative, then you're going to need to flip the picture a little bit. So if the coefficient is negative, then if you reflect about the x-axis or about the horizontal, then your tangent function should look like this instead, if you have a negative coefficient on the tangent. So you'd want to draw your graph more looking like this then, as opposed to an ordinary tangent, okay? So for this problem, since the coefficient of tangent was positive, I drew it looking like more like an ordinary tangent function. Okay, but if the coefficient were negative, then I would have drawn it this way instead. All right. But tangent, I think, is somewhat simple. You just have to pay attention to where the vertical asymptotes are primarily. All right, so any questions about that? All right. So that was, we did problems number 3 and 4 from part 1. Is there any other question that you guys really want me to look at in part 1? All right. So let's see here. Let's go into part 2, and I think I'll do just one problem from part 2, and then I'll spend some more time on the other parts after that. So was there any question in part 2 that you would really like to see me work out right now? Okay, so let's look at, were you thinking of part B or part C for that? Let's see. Okay, so we're going to take like a part 2 problem C. Okay, so we have the expression secant of 3 pi, and then plus 3 square root 3 cosecant of 4 pi over 3. All right. So in order to evaluate this expression, all right, so personally, I find it easiest to think in terms of cosines and sines. So what I would do for myself, just to help me think through the problem, is remember that secant is 1 over cosine. So I could rewrite this as 1 over cosine of 3 pi. And then likewise, I know that cosecant is 1 over sine. So I can rewrite this as sine of 4 pi over 3 in the denominator, okay? And I do that for myself just because for me, I'm more familiar thinking in terms of cosine and sine. Okay. So now we need to know what cosine of 3 pi would be equal to. All right, so thinking about where the angle 3 pi would be. So remember, we start with this direction being angle 0. The angle of pi is 180 degrees, so it would bring you to here. And then if we go around 2 pi, so 2 pi was like 360 degrees, so it brings you back to the original position. So if we go around 1 more pi, it's going to bring us back to here. Okay. All right, so 3 pi is going to give us the same value as the angle of pi would. Okay. And so here from the picture, at an angle of pi, cosine of pi would be equal to -1. So if you remember, you can get cosine by looking at the x-coordinate of the corresponding point on the unit circle. So the x-coordinate is -1, so cosine of 3 pi would be -1. Okay? Okay, so that's how you can think about that one. Okay. Here, when we're looking for a sine of 4 pi over 3, so I remember that sine of pi over 3, let's see here, that should be equal to √3 over 2. Okay, so the angle 4 pi over 3. Okay, so 4 pi over 3, I recognize that as an angle that's in the third quadrant. It's larger than pi, so it ends up being in the third quadrant. And I know that sine should be negative in the third quadrant. So sine of 4 pi over 3, it should be equal to -√3 over 2. And then once I figured that out, then we just need to simplify this now. So this is -1. And we have plus a negative, so I'll write it as minus. And then when I'm dividing by this fraction, I'll simplify by multiplying by the reciprocal. Okay? All right, so we can cancel these square root of 3's when we do that. So that will leave us with -1 minus 3 times 2, which is 6. So that leaves us with the final answer of -7. Okay, so any questions about anything that I did just now? Okay. So I think it's really going to be up to you guys to really be familiar with how the unit circle works. As you can see, you'll need to know how, like, what your trig functions are equal to, like all of these special angles. So being familiar with them and knowing how to like visualize and use the unit circle is going to be important for these types of questions, because you'll just have to sort of know what secant of 3 pi is equal to, for instance, or know how to figure it out. Okay. All right, let's go ahead and move on to part 3. There are quite a few questions here. So let's do a good number of them, all right? So looking at part 3 right now, I'll give you guys maybe a minute to tell me if there are any problems in part 3 that you would really like to see me talk about and go over. Okay, H, very good. K, okay. All right, so we'll look at H and K, and I'll take a look at, I think I'll also take a look at maybe F, so one involving tangent. And maybe I'll look at F, H, K, and I'll look at L. Okay, so let's take a look at those 4 questions. All right, so part 3, question F. Okay, so we have tan inverse of negative root 3 over 3. Okay. So let's talk about how all of the inverse trig functions work. So all of the inverse trig functions are going to output or return an angle within a certain range. Okay. So inverse tangent, what it does is it gives us an angle theta. And for the inverse tangent, this angle theta is going to be between minus pi over 2 and pi over 2. And to figure out what this angle theta is, we want this angle theta to satisfy tangent of theta equals negative root 3 over 3. Okay? All right, so using the fact that we're looking for an angle theta that will satisfy this equation, and the fact that I need theta to be within this range, those 2 pieces of information should allow me to figure out what theta is equal to. Now, thinking about the tangent function, okay, so I know the values of tangent in the first quadrant. So thinking about the values of tangent in the first quadrant, okay, so I know that tangent of pi over 6 would be equal to a positive root 3 over 3. But I want an angle that will give me negative root 3 over 3. So to do that, I know that tangent is negative in the fourth quadrant, so I would need negative pi over 6 in order to get an answer of negative root 3 over 3. So the angle that I'm looking for then would be the angle minus pi over 6. Okay. So tangent of minus pi over 6 will equal negative root 3 over 3. And that would be the angle that I'm looking for between minus pi over 2 and pi over 2. Okay. So then in summary, the inverse tangent of minus root 3 over 3 should be equal to negative pi over 6. All right, so any questions about that one? All right. So let me take a look at part H next. Or part 3, question H. So this one involves the inverse sine function. Okay, so let's talk about how the inverse sine function works. So all of the inverse trig functions, all of them give an angle. Now sine inverse always gives an angle between minus pi over 2 and pi over 2. Inclusive this time. All right, so let's think about this. 5 pi over 3, thinking about where that angle would be in the unit circle. Okay, so I noticed that 5 pi over 3 is going to place me in the fourth quadrant. If you guys aren't sure how to figure that out, so what I think about is 2 pi is going to be 6 pi over 3. So to get 5 pi over 3, we get that by doing 2 pi minus 1 pi over 3. Okay. So 2 pi and then minus pi over 3, so it puts me somewhere in the fourth quadrant. Okay. All right. So in the fourth quadrant, I know that sine is negative. Let's see here, and I know that sine at pi over 3 is equal to root 3 over 2. So therefore, sine of 5 pi over 3, that should be equal to negative root 3 over 2. Okay. So what I'm looking for now then is inverse sine of negative root 3 over 2. And so I already know the reference angle has to be pi over 3 to get root 3 over 2. But I also want an angle that's within this range. So I'd have to use the angle in the fourth quadrant. So I'd have to use negative pi over 3. So that would be an angle that's in this range. Such that sine of theta would equal minus root 3 over 2. Okay. All right, so any questions about this question? Okay, let's look at K and then L. Okay, so in question K, we have cosecant of inverse cosine of 7/9. So let's focus on the inside. So let's focus on the inverse cosine first. So inverse cosine is going to give me an angle theta. And this angle theta is going to need to satisfy cosine theta is 7/9. And also for inverse cosine, the angle that it gives us is always going to be between 0 and pi. And that's specifically for inverse cosine. Now for this type of question though, where we have like a trig function and then an inverse trig function, it's not important that it's not too important that we know what this angle is actually equal to. Instead, just knowing that cosine of this angle should be equal to 7/9 in this case, that's enough to figure out the value of this expression. So the way that I'm going to approach this problem is I'm going to use a right triangle to help me out. Okay. So I'm going to label one of the angles in this right triangle theta. All right, so we know that cosine of this angle should be 7/9. And in terms of a right triangle, we know that cosine is the adjacent over the hypotenuse. So the adjacent side, I'm going to label it with a length of 7. The hypotenuse, I'll label with a length of 9. Now we can figure out the length of the remaining edge by using the Pythagorean theorem. Okay, so from the Pythagorean theorem, 7 squared plus b squared should equal 9 squared. So let's figure out what the length of the remaining edge would be. So if I subtract 49 from both sides, 81 minus 49 is going to equal 32. Okay. So then b should be a square root of 32. And let's see here. If I think of 32 as being, so it's I know it's 8 times 4. So let's think of it as 16 times 2. So if you want to simplify, you could write it as square root of 16, which is 4, and then times square root of 2. All right, so either of these would work, square root of 32 or 4 root 2. I'm not too sure if your professors will want you to simplify the square root of 32 as 4 root 2. So if they don't necessarily care about that, then you could just leave it as square root of 32. Okay. All right, but I figured out the length of this remaining edge. So now what I want is, what would the cosecant of this angle theta be? Okay. Well, cosecant is the reciprocal of sine. And I know that sine is opposite over hypotenuse. So the reciprocal would be hypotenuse over the opposite. Okay. So just using my right triangle, I know the hypotenuse is 9, and the opposite is going to be, I'll use 4 root 2. Okay. So then this would give me the value of the cosecant of this angle theta. Okay. And just kind of writing it nicely, I suppose. So cosecant of inverse cosine, 7/9. So that will equal 9 over 4 root 2. All right, so any questions about that? All right, so then let's take a look at part L now, or question L. So here we have the tangent of the secant inverse, 13 over 6. All right, so this one's similar to question K that we just did. We just have different trig functions involved. So I'm going to start with the secant inverse on the inside. So as I said before, every inverse trig function is going to give you an angle. Now in this case, the angle that we have here should satisfy secant of theta equals 13 over 6. And secant inverse always gives an angle theta, which is between 0 and pi. Okay. Now, just as in the previous question, the actual value of theta doesn't matter too much. So what we can do instead is, using the information here, I can draw a right triangle. I'll label one angle as theta. And then secant is the reciprocal of cosine. So in terms of a right triangle, it would be the hypotenuse over the adjacent. So I'm going to label the hypotenuse as 13. The adjacent is 6. So from there, I can figure out what the length of the opposite edge would be. Okay, so let me call this I don't want to use B because my B might look like a 6, so I'm just going to call this Y. Okay, so if I use the Pythagorean theorem, 6 squared plus y squared should equal 13 squared. So 6 squared is 36, and 13 squared is 169. So if I minus 36 from both sides, it's going to give me 133. So then for the length of the opposite edge, it should be square root of 133. Okay. Now that we have that, we're looking for the tangent of this angle. So then remember that tangent is the opposite over the adjacent. So using our right triangle, it would be square root of 133 and then over 6. So that in summary, tangent of inverse secant, 13 over 6, it should be equal to root 133 over 6. Okay. All right, any questions about that? All right, so let's go on to part 4 then, okay? So part 4 is proving trig identities. So which of those questions in part 4 would you guys like to go over? Okay, so D, I think we can do one more as well. So part 4, question D, and then any other requests? If not, then I will pick one of the remaining ones. Okay, so we'll do part D, and I think I'll take a look at part B as well, okay? So let's take a look at part 4. Question, so I'll look at B first. All right, so here's the identity that we are trying to prove. Okay. So what I will do is I'll start with the left-hand side. And I want to do something to this right now. And right now it's maybe not too clear what to do to get it to become inside. So what I would recommend is just doing something that you see that you can do. There's really nothing wrong if what you do doesn't help you too much. You can always go back and try something different. My advice for these problems though is to don't allow yourself to get stuck on it. Okay. So I think you should always try something, whatever you have in mind. I think the big thing that I see with students is they just because they don't know what to do, they don't do anything. But if you don't do anything, then you'll never be able to figure out the question. So try something, it might surprise you and might actually work, So always try something if you're not sure. All right. Now, this problem here, one thing that kind of jumps out to me right now is trying to multiply top and bottom by the conjugate of the denominator. So the conjugate of the denominator would be the same thing, just with a plus sign instead of a minus in the middle. Okay. And there's a reason why that kind of stands out to me. Try and multiply top and bottom by the conjugate. Okay, so first let's simplify a little bit of what we will get here when I do this multiplication. So in the numerator, we're going to get sine squared times 1 plus cosine x. Now in the denominator, I'm multiplying two conjugates together. And you guys might be familiar that when you multiply two conjugates together, that gives you a difference of squares. And so multiplying these together should give me 1 squared minus cosine squared. Okay? All right. And so 1 minus cosine squared in the denominator. So that stands out to me because I'm familiar with the Pythagorean theorem over here, or maybe Pythagorean identity. So this is one of the main identities that you'll need to know, which will be of help in proving trig identities that they give you. So cosine squared plus sine squared equals 1. So one thing that you can get from this identity is if I were to subtract cosine squared on both sides. So it would tell us that sine is equal to 1 minus cosine squared. So what I could do is, for instance, I could replace the denominator with sine squared of x, because they should be the same thing according to this Pythagorean identity. And then with that, we can actually cancel the sine squared in the numerator and the denominator. And canceling leaves us with the right-hand side, 1 plus cosine of x. All right. So that's one way that we could have gone about proving this trig identity. All right. Certainly not the only way, but that's certainly one way that comes to my mind in particular. So any questions about this right now? Instead of D, can I do A? Yes, I can do that. Yeah, no problem. All right, great. So let's look at question A. Okay, so this question asks us to prove that secant over tangent is equal to cosecant. All right, so In order to prove this trig identity, so I'm going to start with the left-hand side. Okay. Now, when you have a trig identity involving secant, cotangent, or cotangent, one strategy that might be helpful is to just try to rewrite everything in terms of sine and cosine. Okay? And so that's my feeling for what I would do right now. So I'm going to go with that. Okay, so secant is 1 over cosine. Tangent, I know, is sine over cosine. Okay. All right, so that's the equivalent expression in terms of sines and cosines. And since I'm dividing by a fraction, if I want to simplify this, then I would multiply by the reciprocal to multiply by cosine over sine. Okay. So here the cosines would actually cancel out, leaving us with 1 over sine. And then remember that 1 over sine is equal to cosecant. All right. And so that would prove the trig identity. Okay. So then this example illustrates one possible strategy to these problems, which is converting everything into sines and cosines. Any questions about that? All right. So let's go on to problem, or part 5 rather, which is solving trig equations. So I can do at least 2 questions from part 5. So any requests for questions in part 5? All right. Let's go with B and C. And then I think just doing E would also be nice because it involves tangent and it also has a lot going on like within the tangent function. Okay, so let's look at B, C, and E. So we have the equation cotangent of 2x equals 1 over square root 3. All right. Now for me, I am more familiar with tangent than I am with cotangent. So personally, what I would do is just reciprocal both sides of this equation. So instead, we'll have tangent of 2x equal to root 3 over 1, or in other words, just root 3, okay? Okay. Now after that, so now I start thinking about tangent. Okay. So I know that tangent is equal to square root of 3 when the argument is equal to pi over 3. So that's one angle where it would equal positive root 3. That's in the first quadrant. All right. And then I know that tangent has a period of pi, so I could add any integer multiple of pi, and that would give me another solution to the equation. And so for tangent, this would be the general solution right now. But applying that to our problem, so what we have is not tangent of theta, but tangent of 2x. Okay. All right, so the general solution to this equation would be that 2x has to equal pi over 3 plus any integer multiple of pi. Okay. And then now that I know what 2x has to equal, to solve for x, we would just divide both sides by 2. Or if you will, we can multiply both sides by 1/2. Okay. So multiplying everything on the right-hand side by 1/2 will give me pi over 6 plus, and then this we could just write it as n pi over 2. Okay. So then with that, that should give me the general solution to this equation. All right. Any questions about this one? Okay, all right. All right, so let's see here. All right, let's go on to, it was part C, okay, or question C. So let's look at part 5 and question C. Okay, so it's a quadratic this time, so we've got 2 sine squared of x minus 5 sine of x equals 3. All right, so let's see what to do here. Okay, so right now what we have, it kind of resembles a quadratic equation. So here, maybe to try to make things more clear, I'm going to take the sine of x, and I'm just going to give it a new name. I'm going to call it u, so that this would look like minus 5u. And this over here would look like 2u squared. Okay. So thinking of it as a quadratic equation right now, what I could do is, let's see here, it's minus 3 to the other side. So make it equal to 0. Once we have it set equal to 0, then in order to solve a quadratic equation, so I guess we have two strategies. We can either try to factor it, or we can use the quadratic formula to try to find the roots. Okay. So here, I think I'm just gonna go with maybe I'll go with the quadratic formula. So let's do that. All right, so if you guys remember the quadratic formula, so it was what, negative b plus or minus the square root of b squared minus 4ac over 2a. So my a is 2, my b would be a negative 5, and my c would be a negative 3. All right, let's plug everything in and let's see what the roots of this quadratic equation would be. Okay. So negative b is going to be positive 5. So here, b all squared would be 25. And then we have minus 4 times a times c all over 2a is all over 4. Okay. So let's simplify that. Oh. Inside the square root, we have 4 times 2 is 8, times 3 is 24, and it's going to be plus 24 there. And 25 plus 24 is 49. So square root of 49 is 7, so that gives me 2 roots. 5 plus 7 over 12. Oh, sorry, over 4. And I was thinking that 5 plus 7 equals 12, so that would be 12 over 4, which would be 3. And then the other possibility was 5 minus 7 over 4 for the second root, which would be negative 2 over 4, which would be negative 1/2, okay? Okay, so from that, we solved for u in the quadratic equation. But remember that u was equal to the sine of x. Okay, so that's what it originally was. Okay, so from this, we have either u is equal to 3 or u is equal to 1/2. So I'm just going to replace u with sine of x. So either sine x equals 3 or sine of x is negative 1/2. All right, so thinking about these two possibilities, let's start with sine of x equals 3. Now remember that sine is always between negative 1 and 1. So it's not possible for the sine of x to ever be equal to 3. So that means we will get no solutions from this first possibility. So now let's take a look at the second possibility. Sine of x equals -1/2. Okay, so let's think about when would the sine of x be equal to -1/2. So I know that sine is 1/2 at pi over 6, but I want -1/2. So sine is negative in the third and fourth quadrants. So I'm looking for angles in the third and fourth quadrant. Okay, so if I want so I know the reference angle has to be pi over 6. So if I'm looking in the third and the fourth quadrants, I can get the third quadrant angle by adding pi over 6 to pi. So that would be 7 pi over 6. And if I want to get the fourth quadrant angle, one way I could do that is by taking 2 pi and subtracting pi over 6. Which would give me 11 pi over 6. Okay. So these would be the angles in the third and fourth quadrant where the sine would be equal to -1/2. And to get the general solution, I know that sine has a period of 2 pi. So I could add to this any integer multiple of 2 pi to get more solutions. And then likewise, 11 pi over 6 was another possibility. And we can add any integer multiple of 2 pi to get more solutions. Okay? All right, so any questions about that? Okay, so finally, let's look at part E, or question E. Okay, so the equation is tangent of 4x minus pi over 2 equals -1. All right, so first thing I'm going to think about is at what angles is tangent equal to -1? Okay. So let's see here. I know tangent is negative, say in the second quadrant. Also the fourth, but I just need one of them for tangent. So for tangent, I know, let's see here. The reference angle should be pi over 4, because I know tangent of pi over 4 is 1. So I want the angle in the second quadrant whose reference angle is pi over 4. So to get the angle in the second quadrant, I could do pi minus pi over 4 to get to be in the second quadrant. Okay, so one solution to this is 3 pi over 4. Okay. Now for tangent, once we have one solution, tangent has a period of pi. So just finding one solution is good enough, and then adding any integer multiple of pi will give us the general solution. Okay. But here we have something more complicated than just data inside. So here for this to equal -1, we would need the entire inside to be one of these angles. And then what we still have to do then is we would need to, we're actually trying to solve for x right now. So we would add pi over 2 to both sides first. And if I make pi over 2 2 pi over 4, then I can add these to get 5 pi over 4. And then to solve for x, if we divide everything by 4 or multiply by 1/4, we will get 5 pi over 16 plus n pi over 4. Okay, and then that should give us the general solution for this equation. All right, so any questions about anything from that? Okay. Now it's a good thing that we chose to do these questions. So I did notice, because I've been trying to double check what I sent you guys, and so I see that my answers for parts B and E, at least in the answer key that I sent out, they look different from what I wrote down just now. I think they're actually still correct, but they look different. So I'm going to fix that and just rewrite it to make it look the way that I did it in my review, because that's going to be better. And so then when I send out the link to the recording, I'll attach the corrected exam key as well. And I'll also reattach the questions just in case anyone needs that. Okay.